What is a gradient function? Well, let's break it down. Gradient and function. So a gradient, in its traditional sense, when we have a graph, there's our origin, and then if we took it through, in the traditional sense, we would have the gradient being the slope, okay? So it's not just the slope that we're concerned about. What we are concerned about is the rate of change that this goes up. It's the rate that it goes up with respect to our horizontal aspect. So our gradient is traditionally rise over run. Now a function is a rule that determines something. So it's basically an equation. Okay? So we'd have y is equal to, so we could have some kind of parabola, ax squared plus bx plus c, where a, b and c are any kind of numbers. So we'll just put that as an example. In the case of a straight line, the gradient can easily just be a number. It could be, in this case, it could be a gradient of 2. Or it could be a gradient of 1. So for every 1 square across, we would go 1 up. However, not all our graphs are like this. We could have a parabola. We could have a shifted parabola. And on this, there's no 2 points on a parabola where the gradient is the same. It's not consistent. So what we end up with is that we end up with an equation to describe that gradient. So in this case, our vertex is 0 at about here. It's a positive parabola. And it looks like a pretty average parabola. So when we sketch it, let's just change that, dy dx. That would be y, that would be x. Okay, so when we sketch it, our line ends up being a straight line. So we'd have a graph that's a parabola and it ends up being a linear equation. Our gradient is not just a single number. We have a rule to describe the gradient at any given point, so that's why we have a gradient function. Okay, so it's a rule that we can use to find the gradient at any given point. It's also important to note that it's a rate. So in a question where you are asked to find the rate of change of something, or the rate for example, it could be time, or for meters away from a point to find the height, you would differentiate. Okay? So when you need to find the gradient of something, you will need to probably differentiate in order to get that, unless you're already given the gradient function. Okay, let's do a couple of examples, shall we? Let's say that we have some equation. Y is equal to 3x to the power of 4 minus 2x to the power of 3 plus x squared minus 5x plus 10. Okay. Now, when we're differentiating, make sure your notation is correct so you can tell whoever is marking your work what you're working out or what this equation is. In this case, it is the gradient function of y, so we say dy dx. And we do all of these polynomial parts as individuals. Bear in mind that this is being done for a Year 12 course in New Zealand, so I know that there are simplistic ways so that we don't have to expand this consistently. Okay, so the first step would be bring our power down, so 3, and then multiply everything by it. 4 times 3 is 12. X, reduce our power, that becomes 3. Next one, don't forget that we have a negative, so our negative must carry through. 3 times negative 2 is negative 6. X, reduce our power by 1. So that becomes 2. Power down, it's positive, 2x, reduce our power by 1. Don't need to write 1 here. Okay, remember this is power of 1. 1 times anything is going to be that thing. In this case it's negative 5. And then once you reduce the power is to the power of 0. Anything to the power of 0 is 1. Negative 5 times 1 again is going to be negative 5, so we don't need to write anything else. Remember, this just goes to 0. So that's our gradient function. One more example. Let's do fractions. Okay, say we've got some function f of x is equal to 1/3 x cubed minus, 3/2 x squared plus x minus 100. Okay, f dash of x. 3 times 1/3 or 3/3 is going to be just 1, so that becomes x to the power of 2. Don't forget we're reducing our powers. Again, first thing we do is pull our power down and multiply everything by it. So we've got 3 halves times 2 is going to give us 3, but it's a negative, so it's going to be negative 3x to the power of 2 minus 1, so that must make it 1, or just 3x, plus, now don't forget, in algebra, we don't always write the 1 in front of our variable. So 1 times x is just x, 1 times anything is just itself. So we've got plus 1 here. Okay, and we're done. Thanks for watching.